Welcome back to Maths with Indarsina. Today's topic is power and roots. Now let's start. So first we discuss about introduction and terminology part. So you can hear in your previous classes introduction what is power or exponent. We also power exponents that we know the alternate names. Okay. So what is power? A shorthand way to write repeated multiplication number. For example, a into a into a into a, that is a multiple times a. So how we can represent in a short way that the help power portion to write easily a to power n. Here we can write in a nth times that we can simply uh, write in a very short form a to power n. That's the power uses. And here a is the base and n is the power or exponents. Other name is exponents. Okay. Here sometimes we told index. Now here is the base, the number of being multiplied, and n is the exponent, index, power. How many times to use the base in multiplication? For example, if question is 5 into 5 into 5, we simply write them 5 to power cube. That express we get 125. Okay, I hope you understand the powers. What's the uses of powers? Now we'll discuss roots. That other name is radicals, the inverse operation of rising a number to a power. When example a number is rising, something like that, and I want to, that is which power is rising. For example, in a that is come in a root portion. Okay, and their inverse operation is a root and they a into a pair, make a pair a into 1 a, because here if in root, if there is no mention any number, that mean here 2 is always hidden. Okay, if there is no mention here, that mean 2 is hidden here. So make a pair. If here 2, then make a pair 2 digit numbers, and if here 3, then make a 3 digit pair. Okay, so here's the a square. Okay, now that we call, that is a radical symbol. What we told, radical symbols. Okay, for example, in a like that, what is that? Radical. Okay, and what is this? X is a radicand. Okay, that is a radicand, and we can write that under root x is equal to, I already told you, here 2 is hidden, so we can express like that 1 upon 2. If any number in like that, here 2 3 5 n, they always in a denominator in exponent power. Okay, so x power 1 by 2. If here root 3x, we can represent x 1 by 3. So what is 1 by 3? Yeah, 1 by 2, that is a index, power, exponents. Here is the example. If under root 3 27, we factorize 3 9s are 9, 3 into 3, we can note down like that, 3 into 3 into 3. If here 3, then make pair of 3 digits, first, second, third, then outside the root. Okay, I hope you understand how to roots and powers are uses. Now we read few rules. Laws of exponent. For example, if a to power m into a to power n, here base is same, power is different. If base is same, their powers add on, a to power m plus n. And now you can answer, if 2 to the power 3 and 2 to the power 4, what's the answer? Comment in the below. doing same thing, e to the power m plus n. Now that is a product rule. Now we're talking next quotient rule. What is quotient rule? When we divide something a to the power m, a to the power n, their base is same. Now when we denominator goes into numerator portion, that we can write like that: a to the power m, a to the power minus s. A to the power n is the inverse form a to the power minus n, and when we go a to the power m positive in a denominator form, they sign change. If they are positive, they goes into negative. If we are negative, then goes into positive. Okay, now again here base is same, their powers is add on a m plus minus n. Okay, now eighth power m plus into minus, I already explained you in before classes, plus minus is a minus and n. So here is the solution when quotient rule. Okay, then powers of powers, when eighth power m the power n, when we simply open the bracket, we know that when open the bracket, that is come into multiplication form. So here is the eighth power m and yeah, eighth power nm, that is equivalent. Okay, now power of product. Now power of a product, for example eighth power n is equal to n. For example, I explain you: eighth power n into bth power n, base is different but their power is similar, n. So we can simply note down like a b to the power n. For example, I have 2 to the power 2 into 4 to the power for example 5 to the power 2. So we can simply note down like 2 into 5 to the power 2 single time 2, and ab is the same. Okay, 5 into 2 10, then square, and here we 2 square 4 into 5 square 25. What we get? 25 into 400, and 10 square is equal to 10 into 10, also get 100. Okay, also get 100. So power of a power product. Now zero exponential. What is zero exponential is equal to 1. Now I can explain this with a quotient rule. Okay, that is simple for you. Okay, for example, I have 5 to the power 0. Okay, when 5 to the power 0, we can note down like 2 minus 2. Yeah, we can subtract 2 minus 2, also get 0. Okay, now 5 to the power 2 and break their exponents, then 5 to the power minus 2. Okay, when base is same, then power is again add on, then again we get 0. Okay, 5 to the power 2, that is in a negative. When we convert into denominator form, they simply changes to positive value, to 5 to the power plus 2. Okay, now if you clearly show 5 to the power 2 upon 5 to the power 2 is cancel, so what we get? 1. So 8 power 0, if any base their power is 0, also get 1. If 1/5 power 6 is equal to 0, that means 1. And always remember, base never 0. A does not equal to 0. Never ever. If there is a 0, there is not defined. Okay, and negative exponent, I already explained, a to the power minus n. When we convert in a denominator form, in a numerator form, that is a to the power minus n upon 1. If nothing upon, that is a denominator in 1. So if I move to in a denominator form simply 1, then minus n is in a denominator form, just opposite the sign plus n. If e to the power plus n, that goes into denominator form plus n, that here minus n. I hope you understand all the exponents rules. And okay, now here is a few common questions that we can make a error. Okay, 2 to the power 3 into 3 to the power 4 is equal to 6 to the power 7. That is right. 4 plus 3 is 7 and 6 plus 3. No, that is wrong. Because if their powers, okay, when the base is same, then powers add on. Here base is not same, so that never come 7. Okay, that never comes 7. Okay, now when power is same, then the base multiply by same, but here's power is different, so that is not correct. If we want to make a in a for in a single digit a different one, then we make two, for example 3 to power breakdown, 3 into 1, 3 to power 1, we can split like that. 3 to power 3 into 3 to power 1, add on, we multiply 3 to power 4, get. Now we can calculate that 3, what is the their power is same. Now if their power is same, then a to the power n into b to the power n is equal to ab to the power n. That rules. Then 3 into 2 6 and there 3, so we can like that. And there's the final and last step solution. So roots and fractional exponents. Converse rule. I already explained. If any, for example, here, okay, root over m, root over a. So we can explain already 1 upon is m form. Now, if root to power m and a to power n, so how to solve that? Simply just take in a bracket and simply do 1 upon m. We already know that. Then uh, that is a different question. I changed the m and n value in different position. Okay, so now open that we multiply in a convert in a multiplication. So here is the 8th power nm. Okay, I already, okay, now I explain this. Otherwise you confuse how there is a different and okay, now I explain this. A, again n, here what is mentioned n, so 1 upon n, what is the value is 8th power n. Now here how can I note down like that? Just 8th power m and 1 upon n, so we can note down a to the power m into 1 upon n, so simply a to the power m upon n. Okay, so answer this. You already know that under root 6 here 2 is hidden, so there is pair 6 into 6, so 6 is outcome. Yeah, otherwise you can also note down like that, 6 square and convert into 2, then 2 to cancel, then get 6. Okay, here 64, here 3. If or I already told you, if other than 2 they also mention the numbers. Okay, if other than 2 they also mentioned, I something meant to explain. Okay, okay, here you can see that if any index except 2 they properly mentioned here. Okay, for example here 2 is hidden, sometimes 2 is here, you can see that 2 is hidden, here index is hidden, but other than 2 they are properly mentioned, like here 3, you can clearly show that 3 root 64, here index is clearly mentioned. Now we make a 64 in a pair of 3. Okay, 4, 16 into 4. Okay, 4 into 4 and 4 ones are 4. Okay, 4 into 4 into 4, here 3 is mentioned, so make 3 digit pair. So what's the answer? Solution is 4. Now cube root, explain square root completed. Complex conversion, I already come. Here is the easiest way. I already told x power 3. Here is the question is 4 x cube, just x power 3 and index convert into 1 upon in a denominator form 1 upon 4. then just multiply 3 upon 4. Now that is a very important real life application that make interesting this chapter. Otherwise, like why we are study this? What's the real? What's the our daily life uses? Here's the example. Why we read this chapter and what's the need? Why these chapters need to discuss in our class? Okay. Computer memory power. Here example. If you already know that 1 GB you are using internet, so you already know 1 GB data I have pack. So how many is 1024 MB? So again breakdown 1024 MB. MB is 1 MB is equal to 1024 KB. Then 1024 KB is equal to same portion here. Okay, into 1 KB is equal to 1024 bytes. And again you here's the fraction, so we can note like that is uh, a lot of numbers are there, so we can just put the simply when we multiplied all these numbers we get to the power 10 values. You can multiply all this 1024 into 1024, how look like a in a big number, and that is a time taken to note down everything, so we can simply write them to the power 10 bytes. Bytes is their units. Okay. Now next, population growth and compound interest in exponential growth. Okay, compound interest, if you are a simple interest, compound interest that you read, that helps the portion to solve the problems. Okay, population growth, if a is equal to here a final result, what's the population after how many times, like here note down is a is equal to p 1 plus r to the power t. Okay, here p is a current population and after t is time 5 years, and growth rate is 5%. If 5%, then what's the increasing rate, then you can calculate 5 into 2 into 21, and you can solve them, then that's help you for found the population growth and compound interest. Earthquakes, when earthquakes comes, the reactor scale, what's the unit for measurement of earthquakes? Reactor scale. A earthquake of magnitude 7 is not twice as strong as magnitude 6, so it is 10 to power 1 times stronger because the scale is logarithmic based on a power. Okay, earthquake magnitude we can use to uh, the house the magnitude, the earthquake that is damage, and we use in architecture and construction square roots, if like that, if here just a second, I give a brief information on, because I discussed this chapter, this portion in a separate chapter, because that there are a lot of information and in competitive exam related that is very important, so I can explain in a separate video. I just explain their terminology. Okay, here Pythagoras theorem, for example, their side is a and b and here c. If we use Pythagoras theorem, just c square is equal to their side is square equal when a is square, for example triangle is abc, when their two sides square is equal to their hypotenuse, what we call there is a base, and there is a perpendicular, what we told perpendicular, there is we called hypotenuse. Okay. So c is square, yeah, here when you convert in a root over a square plus b square. So now you can comment in the below, I can provide you answer in the below. Okay, what is the comment first? Yeah, take pause and then calculate and then answer. That is a simple. For example, one question I explain you for 3. So let's solve with me. Okay, 3 to the power 3, open the bracket, x square into 3 into y to the power 4 into 3, that is the complete power 3. So 3 is the index that come with every number. Okay, 3 to the power 3 is a 27, and x to the power 6, and y to the power 3 into 6 into 4 into 3, 12. So here's a solution. Now 81 to the power 3 4, we if we 81 to break it, that is come with 3 table, 3 into 2, and 6 into 7, 3 and 7, 3 into 9 into 3 into 3 into 3. Here 3 4 times, so we can just 3 to the power 4 into in power 3 to the power 4. So 4 4 cancel, into 3 to the power 3 is equal to 27. That is true or false? Okay, now explain. I already explained you. uh, there is a addition, so we can true or false. That is totally false. Why? Because when there is a solve in multiplication, if their base is same, then power is addition. Here power, okay, here addition sign are using, so that is a wrong. Okay, when we multiply by 2 to the power 3 into 2 to the power 4, then 2 to the power 7, that is true. Now section B, application and problem solving for x power 2 to the power x plus 1. Okay, 2 to the power x plus 1, and here 32. Now 32 factorize 2 to the power 16, and 4. I take a always take you prime factorization, always 2 take. If 2 is not divisible by, then 3, then 5, then 7, and so on. Prime factorization I can directly use because I am expert in this. So I took directly. Here 2 to the power is 1, here 2 to the power 2, and here 2 to the power 2. So 2 2 4 8 1, 2 to the power 5. So here, okay, now note down completely 2 2 into 2, 2 into 2 into 2 into 2. So just 2 to the power 5, here 2 to the power x plus 1. If their base is same, okay, then x plus 1 is equal to 5, then x is equal to 4. Don't cut like that, we are just comparing. Okay, here just comparing. So what's the 2 to the power x plus 1 is equal to 2 to the power 5, here equal. So just we x plus 1 is equal to 5 because their base is equal. If you that is understanding for difficult to you, just here you rule the AB is equal to CD. Okay, A upon B is equal to C upon D. Just a second. Okay, now I explain you. For example, A upon B is equal to C upon D. How we can in a numerator form we'll note down like that. We just multiply by A into B. Just shift into another equal side into B into C. So A upon B is equal to C upon D. We can like that AB is equal to BC. Okay, simply here 2 to the power x plus 1 is equal to 2 to the power 5. Just a second. So how can I note down like this question? My battery is low. Just a second. Okay, I on the switch. Okay, so what we discuss? So when we come in a here, okay, so what we get? 2 to the power x plus 1 in denominator, 2 to the power 5. What we here? 1. Okay, then so what we do, that you make a difficult, that is the easiest way, but okay, I continue the complete the question here. Then denominator form come into a multiplication to the power minus 5, then 1 we can note down to the power 0. If any the power 0, that is 1, so we can here base is 2, so we can to the power 0, then we can solve that. Just here I can solve that to the power x minus 4 and to the power 0. So here base is again equal, so just note down x minus 4 is equal to 0, x is equal to 4. Don't do this, like that is very time taking and time consuming and difficult to understand. Just you solve that, like if to the power x, just we factorize and their power comparison with power x plus 1 is equal to 5, x is equal to 4. That is the correct answer. If you took that is longest way, that is not do for time taken. But if you know that how to tackle with this type of problem, here is another method I can explain you. uh, okay, now next question is, so what's the next question is, okay, how to solve this. We here 481. Achha, complete the power is 3. Okay, just okay. I already told you 81. If you factorize 3 to the power 4 comes, then 1 by 4. Their complete, their again complete power is 3. Here when you open the factor is 3, and 3 to the power 3 is equal to 27. Achha, oh, okay, I explained you. Okay. Here's the question, sorry. Question 4 I explained. Geometric link area of plot is here. The area of a square plot. Area of a square. Here is the square form area. Their side A. So here, what's the formula of area of a square? Side into side. Side into side. Here side is length and breadth is equal, so directly we a into a, yeah, a square is equal to, what is the value given, 1140 1140. When we move to root, when square is moved to right side, they convert into uh, root form. Okay, here index, when we convert into other side, they convert into a index, yeah, root. Okay, okay, index root. Okay, so 14400, 144 into 100. So directly I note down 12 square into 10 square. You can factorize prime factorization, then you have the complete solution. So here to 12 square pair is 12 into 12, and 10 square 10 into 10 pairs. So what uh, so what come outside, uh, 12, sorry, what's come outside, 112 and 110. So here when you calculate 120 centimeter square, here's the solution. So question number 4th is I already explained. Now I erase this portion because that looks so, delete. Okay, so next question is 6th. 5th I already discussed. Now, sixth question. Scientific notation. The distance from Earth and to the Sun is approximately 1.496 into 10th power. What is noted here? 8. Okay. 10th power 8. Here is the distance between Earth and Sun. So if we square this, then distance of physical calculation, what is the value when you square this? That is a very big challenge. 1.496 square into 10th power 8 into 2, so 10th power 16. So that is very difficult to solve. So what we do, just take a approx value. For example, 1.49 is nearest to uh, 1.5. Okay, it is the nearest to 1.496 is the nearest to uh, assume that 1.5. Okay, then what we do, okay, here I explain in a different detail. When you remove the decimal portion, that is come into that form. Okay, now here complete square. 15 square is equal to 225 and 10 square is equal to 100. I assume that is a approx value, not their answer might be different. Okay, but that is a nearest value, because here point and when multiply by point is give me a lot of values. Okay, when 3 things 6 times, that is create a hurdle for me. So what we 120, so directly put decimal in after two digit 1 2. Here's the 2.25 and power is 10 to power 16. So here's the approx value. 2.25 is 10 to power 16. So here's the solution is nearest. Here we can see that 2.2 and 2.2, then 5 approx. Here 3.38. Now advanced PGT. Okay, rationalization method. 1 upon root 2. I want to remove this in a denominator from root 2. So what we should do? Just multiply same thing in numerator and denominator. Root 2 into 1 root 2, and there is a pair 2 into 2. So one pair is outside, then root 2. Simple. For denominator, like the 3 plus under root 5. Okay, denominator is 1 upon 3 5. I want to remove this. So what we do? Just plus here. So divide, multiply with the negative numbers. 3 minus root 5. 3 minus root 5. So what we get now? Here numerator form is simply 1 with multiply by 1 and 3 here. A plus b and a minus b is equal to a square minus b square. Here's the formula we use: a plus b, a minus b. We can clearly show a plus b, a minus b. So note down a square minus b square. That means 3 square minus root 5 square. So what we root 5 square is equal to 5, then 1 by 2 into here power is 2. 2 cancel, when bracket open, that is converted into multiplication. Here is the 5 value, and 3 square is equal to 9. 3 root 5 9 minus 5. So what's the value is 3 minus root 5 is equal to 9 into 9 minus 4 5 4. Now you can solve this question 1 upon 3 minus root 5 and comment in the below. I hope this video helps you power and index exponent chapter everything crystal clear. If you have any doubt, please comment in the below. I make a definitely and clear your doubts. If you want any topic to make a videos, please comment in the below. I will definitely make a video. And please subscribe mess with Inder Sinha and join Telegram group. I really need your help, so please subscribe, because that motivate me to make a videos. Please subscribe again, and thank you so much. If that's help and clear your doubts, if you have any doubt, then comment in below. Thank you so much. Bye bye.